Okay. So first I'll give you an introduction of the OCR, and then I wanna describe as a photo OCR problem. Basically this problem based on how to get those content from the photo. And also gonna talk about how to solve this problem by using a photo OCR pipeline. Then I'm gonna describe in this pipeline, there's the different modules and how each individual module works. Yeah, basically that is my outline for my talk. Oops. Yeah, so this for OCR, what is OCR? OCR is the optical character recognition, and because before when this got invented, it's original for the blind people who cannot see. There's a readers, so we use this OCR optical character reader. They can make them can know what is the characters to convert to the character, though they will know. So it's a mechanism or electronic conversion of the image or typed or handwriting or printed text into a machine encoded text to make the computer knows. So from the photos, so we'll make the computer knows what the contents in this image. So there's a variety of applications in there. For example, when you want to save a check, or you want to check into an airplane and scan your passport. Also, there's the invoice bank statement, and maybe you want to save your receipt to get the content out of your receipt. Also, for the self-driving, they will automatically recognize the signs or some plate numbers, the car's plate number. And also, by using this OCR, you're able to search the books. So if you only know the content of the book, you can just search a keyword. Then it's able to find a result from some PDF or something. Also, for the handwritings, you can just handwriting something, and they also automatically convert your handwriting to the real characters. And I think the most awesome application is the Google Photo. So, we have a cell phone. Everybody use cell phone to take a ton of pictures every day. So when you upload to the Google Photos, so one day you want to search something, you can just type in the keywords, then will automatically pop up all these results from your pictures. So I think it's really awesome features. It's really convenient for our life. So there's a many ton of advantages in there. Once we have like a printed page or photos, but the content is able to is able to read by the machine. That'll be, we can do all those kind of things we cannot do before. Also, the major use, I know in the early age, the first users for this OCR is for the blind people. They by having this OCR technique, they're able to read those printed book out for these blind people. So that is the original I think the purpose to why they invent this technique. Okay. So let's talk about this photo OCR problems. So with the growth of photographs, so also our cell phones able to take the pictures, a lot of pictures. So everybody took the picture every day. We have so many pictures. So with the increasing this amount of pictures, our developers are more interested to let to know what exactly the content in this picture, and they want a computer to better understand our pictures. So not only this, also for the blind people, for example, when they're walking on the street, they want to know what exactly in front of them. So if we have some technique when take a picture, then the blind people will know what exactly in front of them by knowing the context. from this picture. Also, for the increase like a self-driving car, when they drive these cars on the road, they will automatically recognize what is the content of the sign, what does the sign say, something like that. So if by the given the picture like this, so it will be nice to let the computer know exactly the text in the picture. So how can we know how can we solve this problem to know what's the context in the picture? So there's a few steps in there. So first we need to know what is the location of this text. So for example, in here, you'll see this red rectangles. So these are the regions where the text appears. So first we need to find these rectangles. We know this rectangle here, and we need to find some text here, and also there's open here, and some other places. So the first step, we need to know those regions which include the text. And the next step, once we know what is the regions we include this text, hopefully we can correctly come up with these transcriptions. So for example, once we have this rectangle, and then we do some analysis within this rectangle, hopefully we will know, oh, this text this is Lula, bees, and Tigmo. So hopefully we can get this text correctly. So that is the second step. And see that also here. So actually this photo OCR problem, machine learning problem, is more difficult than the scanned document. So if you have like a scanned document, to recognize those characters is much easier because it's kind of like more clear, and easier to recognize. But this text on the photo, because sometimes your focus is not very good, or text is very small, or something like this, it's in a transparent glass. So that's somehow it's super hard to know what exactly this character is. So do the OCR on the photo is more challenging than a scanned document. So here's our way to solve this photo OCR problem. This is the OCR pipeline. So we have basically 3 steps. So first step, we use the text detection. We want to know where those texts located. We would like to find these rectangle regions in this picture, and that is the first step. And then we'll do some character segmentation. That means we need to find a line between the 2 characters which can separate 2 characters. So for example, in this row, antique mall, we try to find these lines which can separate 2 characters. So yeah, those are result is like we use this multiple line to separate this character. That is called character segmentation. And the third step is once we have this segmentation, we are gonna get individual letters. So for each letter, hopefully we will know this letter means A, and this letter means N, this means T. Yeah. So that is the basic 3 steps in this photo OCR pipeline. Of course, there's some special case. So for example, this. So once you have like this third step, character classification, for example, you have like this, it will come, a result comes with like, instead of this is 1, this may be hard to recognize this as a 1 or L. So it may after it's translate the result, it may think, oh, maybe this is 1. So this is a kind of more complicated OCR problem. So for some more complicated OCR system, they have system called correction system, which can deal with this kind of errors. So when they see like CL, C1, blah, blah, so this shouldn't be the 1, it should be the L. So, but in our case, I just make things more simpler, just include the basic, very simple step, so we don't think about some more complicated cases. Also, when I read this tutorial, I will also think about if it's this line or this rectangle thing, those character maybe not vertical, it's a little bit shift or rotate or something, how are we gonna deal with that? So I think there should be some more complicated OCR system is able to deal with more complicated. But for this, I just give a very simple, I use the basic example to describe how this basic OCR, photo OCR works. So here is the overall view for the OCR pipeline. So once we have the images, those images first go to the test detection. Then we need to know which is location of this test, find those rectangle regions. So once we have these regions, we're gonna find the character segmentations, and we'll see, try to separate out each letters within this region. And then we'll do the character recognition, how to find out each character, what this character exactly this character is. So actually in many complex machine learning systems, this sort of pipeline is pretty common. So where you have different modules in there. And each module actually is a machine learning module or maybe not. But the importance of like designing this kind of machine learning system to solve a problem is how to decide it, how to break down the system into different modules, reasonable modules, and that's the people working on this. So also see if each module maybe have a different performance, and each performance also impacts the overall performance. So when you're designing the module system, machine learning module like this, so you need to think about the performance and whether this chunk of the module is the big or small, is able to how many people were working on that. So if a team, for example, is a team working on a machine learning system like this, so maybe like a couple of people, maybe 5 people working on this, or then maybe like another 5 people working on the character segmentation, or maybe another 5 people working on this. So that is how the team working on this machine learning systems. So next I want to talk about how exactly each module works. So the first one is the test detection. So the purpose of the test detection, we want to find out those regions where this text located. So for example, the result, the input is this image, and the output, we want to find these rectangles. So make this problem a little bit easier to describe, to solve. We first take the pedestrian detection as an example. So pedestrian detection is by giving this a picture like this, we try to find out where is the pedestrian located. So for example, in this picture, we have like a 6 pedestrian. We want to find these rectangles here. Like where's the people? There's a people. There's a people. There's people. There's people here. So yeah. So basically, this problem is a little bit easier than the text detection because this rectangle, the ratio is the fixed. So this width and height, we can say that's the fixed ratio instead of this. This rectangle maybe it's not the fixed, it's maybe the different ratios. So this rectangle maybe have a bigger or smaller. So if the people more closer to the camera, so this will be more more bigger. And if there's a more further, you will see these people's were more smaller. Yeah.
So nowadays I notice sometimes when I drive, I see the red and yellow lights. Like I feel like they kind of can detect whether they have a car is waiting. If they do, then they will switch to the green light earlier.
That's a different problem actually. I think that's the detect the object. Like they maybe can detect the object.
The pedestrians.
Yeah,
object, right?
Right. This like I want to find out exactly location it is. Yeah, probably is yeah, maybe a little bit, but that is more easier because you just need to know like here's the object in front of you, and there's a car. Yeah. I think maybe we can see the same thing.
When there are more cars, the green light will last longer.
Maybe some sensor will detect. Oh, there's a car in front of you. We can detect there's a car in front of you.
This same technology.
Maybe or yeah. There's I think in that sensor like a car detection maybe called. So when there's a car coming, it's usually no car is always red. So there's a car stopping there.
Yes,
they will detect that there's a car there.
Yes.
Yeah, probably. Yeah. I think so. Maybe it's the pedestrian detection. That one is a car detection something. Yeah, we detected the car, then we'll turn it to red, turn green. Yeah, I think so. Yeah, I think you're right. So to know how can we detect those pedestrians in the picture? So we use the supervised learning for pedestrian detection. So first we collect a large set of the training examples, which have the positive examples and negative examples. So the positive example, that means this picture, this like image patch, includes the people in there. So we'll see the positive example all include the people. And the negative example, that means this picture, this image patch doesn't include the people. So the training example can be like larger is better. Like you can have like a 1,000, 10,000. Then you use this training example to train a classifier. We know this positive example is the y is equal 1 and this negative example equals 0. So once we have this classifier, then we can use apply it to our images. So here we're gonna take a rectangular image patch in the left top corner. So once we have this, we're gonna run this image patch through the classifier, and then we'll determine whether this image includes a pedestrian or not. So for example, here we're gonna take this to the classifier. So and then our classifier will know, oh, this doesn't include the pedestrian. Then they will know. Then they won't mark. So then we'll move to this rectangle a little bit right, and also continue to detect. So there's a step size, like how much we're gonna move. I think it's depending on how accuracy, or it's depending on if it's a smaller, of course smaller is better, but it's more time consuming. So it's depending on you. You can set it like a 1 pixel, that's the best. You can also take like a 4 pixel, 8 pixels. It's totally depending on how you wanna run it, how accurate you want. So this rectangle will like sliding window. It will continue like run like this, row by row. So until you find the people, then you will know. So for example, if the rectangle is here, then they will know, oh, there is the people in here. Then they find the people. So
increase the rectangle.
Yeah. So here, so then actually this size is fixed. It's because I already said this pixel is 82 by 36. So it looks like increase. Actually, I just make this image more smaller. Then this rectangle will become bigger. So this size is fixed. Just will change the size of the image. Yeah. Then we'll find also it run the same way. You're just running like a line by line. Then we'll find these people. So hopefully the result will be like this. You will find this is when you run with a smaller rectangle, smaller window. You'll find the people like this. When you run with the bigger window, you will find the people like this. So that is our final result for the pedestrian detection.
Isn't that incredibly compute intensive to try like every possible rectangle at every possible size? I mean, there's got to be a better way than that.
Yeah. So actually, you can just like make this image a little bit smaller. This step size, you can decide. You can decide the step size, like how much you wanna make this image smaller. So of course, this step size is smaller, the result will be better. Yeah. So, but it's more time consuming. So you should find a trade-off and what is the best balance, what is the best trade-off. You can make this algorithm have the better result, but it's the best speed. So you can just like it doesn't have a. I think probably depend on the images, or the quality of the image, or how many people in the images. You can do a lot of experiment to change those parameters to play with, and finally, what is the best result is gonna be. Yeah, I think machine learning problem usually you can doesn't have a deterministic solution. So many things you can play with and try to make this result as fast as possible. So back to our broad test detection problem. So our purpose try to find these regions where this test located. So that is our goal. So similar like pedestrian detection, we also need to find this labeling. First of all, we need some large set of the label training set. So positive example, something like this. They have all characters here. That is the test we want. That is the thing we want to find. We're looking for. We're focused on, and this kind of the set that is something we are not looking for. So we said this is the negative example, and this is 0, and this is a positive with what we are looking for, which is 1. So we put this labeled training set to the neural network or some other learning algorithms to get classifier.
The data set.
Yeah, that's a training data set. Yeah, training data set. So as of course you can find as more as possible, better. Yeah. So
this looks very
yeah, of course this is very small. Usually it should over maybe 10,000, 20,000, and more is better. Just put this here. Especially the photo, when you take the photo, those characters can be all different kind of when you take a photo to the restaurant or some other place in the street, so those characters appear in the photo can be all different shapes. So of course, the more data you have, the result is better.
Can I speak? Yeah, I just wanted to say that so in machine learning, having more data won't always be better. Like there's a threshold, or it's after which if you add more data, then it gets you get overtrained. So yeah, I just wanted to make that small point. Sorry.
Okay. Yeah.
You can't have too few data, or you can't have a lot of data.
Oh yeah. I think so too. Yeah. I think you are right. Yes. Yeah. So yeah. So for the test detection, so when you have also similar to the pedestrian detection, you use sliding window. So we first take the left top, this square, and then we'll run through the classifier. Then we'll know whether this is the include the test or not. So if it doesn't include the test, we're gonna mark like a black. So if they have the test, for example, like this, see this red arrow, so they have test gonna mark like a white. So when you run this classifier, it may have they will have the possibility of the output from the classifier will know whether how confident they have the test or not. So it will represent like this shade of gray here. So you will know if it's very white, they have a high confidence that is the test. If it's a little bit darker, that's the low confidence they have a test. So that is how these images represent the result of the test detections. So you will see this black thing definitely doesn't have the test, and this white, you see the white, we have some possibilities to have the test. So after we have this picture, this black-white result, actually the test detection is not done yet. Because the final goal of the test detection, we want to draw rectangles. So we are gonna have it's called expansion operator. We apply the expansion operator on these images to get the image like this on the right side. So we make this, we're gonna expand this white region to white rectangles. So the result will look like this. So how can we make this? So how can we do this? How can we implement this? So for mathematical perspective is we take for each pixel in this images, we're gonna find whether there's a region, whether there's a white region within some distance. I don't say. So for each pixel, is there any white region with some distance? So for example, here, oops. So if they find that, if for example, if you find a pixel which is black, but within some distance, for example, there's a 5 pixel or like a 4 pixel, there's a white region. So you're gonna mark this region as white. So you change the black pixel to the white. So that is how expand this white regions, rectangular, changes to a rectangular white region. So once you have this one, you will see some region is like a rectangular, like a white shape. That means that is the region we're looking for. But some region like this, you find that is like a stripe. The width is the height is longer. So we're looking for the rectangle will have the wider width, right? Wider width than the height. So if you see this the height is larger than the width, actually these things is not what we're looking for. We're only looking for this thing. So yeah, so that is the test detection. So next one we'll do the character segmentations. So similar like the previous training techniques, we're gonna use this as our positive example and negative examples. So the purpose of this step, we are trying to find a line between two characters. So these positive examples, so you will see if there is Is there a gap between the two characters? So these are kind of the image path that's what we're looking for. So you will see there's a L or E or something. So we'll see there's a gap between these two letters. So that is the thing we're looking for. So there's a WT and there's a gap in there that we're looking for. So we'll put this kind of the data in our training set. So label as the 1, and you'll see these pictures, and you'll see there's no gap between two letters, and also there's an empty one. So this kind of images is the negative examples. So that's not something we're not looking for. We put in the negative examples. So after we get the classifier, we're gonna run this in our this test region here. So we're gonna run this from here, and then we found this one. Well, first we'll say this one, this is not what we're looking for, and then next one, there is something we're looking for. So we're gonna keep running. As also use because this is the only one row, so we call that 1D sliding window. If there are multiple rows, then we probably call that 2D or something. Yeah, so this for the simple example, there's just 1D sliding window that keep running through, and then we'll find. So finally, we'll find all these lines between two characters. So we'll know, there's we can separate out each character. So that is how the character segmentation works. And for the last step is kind of easier. We already know how to train, how to use the supervised algorithm to find out those characters. So hopefully we have a good classifier which can tell us, this is the letter A, and this is letter N, letter T. So just a similar way can do that. So in conclusion, there's photo OCR pipeline. So you can see there's 3 steps. So first, we find the tested regions in the pictures, find these rectangles. We know where is test located. And then we do the character segmentation, try to separate out each characters. Then we'll know what characters there, what each character is there. And then we'll do the character classifications. And once we know this character, we'll know what is this character, exactly the character is. Yeah. So that is the photo OCR pipeline. So in conclusion, in this talk, I talk about what is the OCR and photo OCR pipeline, describe this photo OCR pipeline, and also everybody knows how each component in the OCR pipeline works. Yeah, that's all my talk. That's all. Hi, do you have any questions or anything?
I had one question, which is a follow-up to what Bill was asking. So when you're looking for pedestrians, you knew the size of the rectangle, and then you were looking at all possible subsets of the rectangles in the image. But let's say when you're looking at text, how do you so you look at all possible sizes for a particular size of rectangle, and then you also have to look at different sizes of the rectangles. So, right, you have to look at the different sizes of the box. So won't that be pretty huge computationally?
Yeah, I think so too. For this pedestrian, it's a bit easier because they have the ratio is fixed. So you will know what is ratio. You just need to change the size of the picture, then you'll find all the pedestrians. So for this example, for photo test detection, that will be more complicated because you have to know what is the size of the pictures. Let me see. Yeah, maybe this one is better. Yeah. So the size of this character, you don't know. So I think probably you have to, this size you also need to change. So you have to try the different, like a different size of this. This is a training set. This is very small. I'm not sure like what is the best or what is the initial size they're gonna put in the classifier. I guess you probably have to try the different sizes to run the multiple times or something. Yeah, but there's no, you don't know exactly in there, or maybe because I didn't read some more. I just learned this. I'm also new for this. I just learned a very basic one. So, but I guess probably they can do some pre-processing or something. They will know what is maybe. They will know what is the best initial size for this image patch to start with. Then maybe running the different, or what is the best step size to running, the smaller one, you get the better one. It always has to be tested out. So yeah, so that is my guess.
Okay.
Yeah, Diana, question or something? Actually, I also have a lot of questions for this because I'm also learning and reading the materials. So yeah, one is like if the character is not vertical, or if it's a different, different rotate, how they're gonna detect it? They're gonna rotate the picture, or how they're gonna know that? There's a lot of I don't know how they're gonna pre-process those pictures. Otherwise, if they cannot just follow one standard way to to analyze all the different possible pictures. So actually, I have those questions too. I would like to know. Also, I know there's some places, for example, when you log in, I don't really know how to say that in English. It's that when you log in something, but sometimes they will manually pop out the image and ask you to manually type in what you can see that world and then know, but it's very difficult to OCR. If that image can be OCR, that means that picture is not good. So these kinds of characters may be like a super hard to be recognized. So I guess if this characters in the picture is so hard to recognize, maybe even OCR, some very advanced OCR cannot recognize those people. But I think with the improvement of this OCR technique, they probably in the future they can find a way to recognize those very difficult, hard to understand characters. Yeah, but I'm really curious how they're gonna solve those kind of problems.
As far as I know, that usually the OCR problems, they so if there is a particular style of handwriting, then they would have the training data for that sort of handwriting. Mm-hmm. Like the example which you gave us, it had different fonts of different sizes, and so if you were to train for that, you would have to have a pretty huge data set having different types of examples in it. But normally, I think OCR is used where for a very specific problem.
Okay. Yeah, for example, if I wanna really recognize those very hard to, so you said you wanna recognize some set of problems, maybe use the special set of the learning image patch. You can recognize. Okay. Any other questions?
I don't have it.
Okay. So if have no questions, I'm gonna drop off. So that okay. So see you next time.
Yeah.
All right. Bye bye.
Bye.
Bye bye. Let's stop recording.